Hello, class. This is, of course, part 2 of the review video. We are right on the proof, so we'll start there. Proof 9 says we're given that AC bisects angle BAD, BAD, and also angle BCD. So this is a bisector of both angles. So what that means is if this is a bisector of both angles, it's going to cut both of this end angles on, I'd like to call this a kite, and make those two congruent and also these two congruent. That's the information we're given from the fact that AC bisects BAD and angle BCD. Now we also know it's congruent to itself because it's reflexive. That's our mark. That is what we need to mark on this kite from the given information, and that allows us to state whether the two triangles are congruent. With that information, we have an angle side angle. As we go across, we run into an angle side and angle. So it's an included side, and that's going to be pretty easy to prove that the two triangles are congruent, which is what we're asked to do. So the first thing we're going to state is that AC bisects angle BAD and angle BCD. That's given. From that, we can state that angle CBAC is congruent to angle BAC. And also, angle BCA is congruent to angle BCA. And we can state that those two angles are congruent, the two sets of angles, by definition of bisects. All right. All right, so the next thing we're going to state, we've stated the angles are congruent. Now we just need the side between them, the included side. So 1 to 2 is AC, is congruent to AC, right? We go AC to AC, and that's because of the reflexive property, their shared side. I like to say the true name of it is reflexive property of congruence. And now we have an angle side angle proven to be congruent to each other as those corresponding parts. So therefore, triangle ABC must be congruent to triangle ABC. And that's by side angle, side angle. Right? So that's number 9 for the proof. Now we'll move on to number 10. Number 10, we have BC is parallel to AD. You know how I like to mark these. If those two lines are indeed parallel, then all of these little crosses are going to be transitive, or those transversals that go between them. So that's going to be pretty easy. We have a lot of set of angles that are congruent. These are the two triangles, so let's see if we can get one of each. If this is a transversal, this is a transversal, then this angle is congruent to this angle, right? They're unobstructed by the other sides, which are kind of important. That's the only thing that's attached to one exact line. We also know that this side is reflexive and congruent to itself, and we know that angle A is congruent to angle C. So that's how you would mark that up. Now, I couldn't state these two angles are congruent by the alternate interior angles because this and this have been obstructed by another line. So only these two angles are not obstructed by another line. They're just between the parallel line and the transversal. So what do we have? We have angle, angle, side, don't we? Angle, angle, side. So angle, angle, side. So we're going to be given that BC is parallel to AD, and that was given. And then the second thing, or what we get from that given, is that these two angles are congruent. Now, you can't say angle B because we have two, so to be inconclusive or ambiguous which angles we're talking about. So we need to say CBD angle, CBD is congruent to angle. We went from 2 to 1 to none, so 2, 1, none, ADB, angle ADB. And that's by alternate, they are alternate interior angles. And that is actually a theorem. Might as well state that. And then the next thing that we know is that, so we have that angle. Let's hit these angles. They're given. So angle A is congruent to angle C, which is given. Now let's hit this side. We need to state the side is congruent to itself. So let's go 1 to none. So in this triangle, it's B to D is congruent to, and this angle 1 to none is DB on the left there. And that is the reflexive property of congruence. And now we stated angle, side angle. All three of those have been given. So last but not least, we can say, oh, we're not done yet, but triangle, let's see, none, 1, 2. So BDA is congruent to triangle, none is D, 1 is BC, so DBC. And that's why angle, side, and then because they're congruent, every corresponding part is congruent, and therefore AB would be congruent to CD, which is AB right here is congruent to CD because those are corresponding parts of a congruent triangle, which is CPC. All right, so those are our final, zoom out so you can get it all at once. That's our final side, all the proofs. Woohoo! We're done. All right, there are your review videos. Have fun.